Title: Cell Biology and Biophysics. Cell biology introduces a key concept, the surface area to volume ratio, which limits the size of cells. In physical space, proportional scaling up or down changes the mechanical properties of objects. For instance, humans might suffer severe injuries from a high fall, while insects usually remain unharmed. For insects, air and water droplets are much more viscous than perceived by humans. For example, elephants have a slower metabolism, requiring large ears for heat dissipation, while mice, with their rapid metabolism, rely on fur for insulation. These variations in physical properties due to spatial scale also affect the way information is propagated. Title: On the Origin of Human Inequality. In general education, we learn about simplified uniform fields, such as uniform electrostatic and gravitational fields. However, perfectly uniform fields do not exist in the real world. This non-uniformity creates unique snowflakes and leaves, and similarly, it leads to the differentiation of individuals and the natural stratification of society. The diversity of phenomena in the macroscopic world fundamentally results from these non-uniform fields. The primary reason people fail to learn from history, leading to the rise and fall of dynasties, is not that they can't understand the lessons, but rather because their choices are limited by their specific circumstances, leading them to inevitably repeat similar mistakes. On a deeper level, humans might be considered not just slaves to their genes, but also to the laws of physics. Title: The Diversification of Inequality, a Perspective from Information Science. A form of inequality structure widely present across various spatial scales is the tree structure. For example, the human nervous system and the national administrative system, computer memory, is designed with a hierarchical system based on speed and capacity. And the South Bridge-North Bridge architecture on the motherboard is designed to solve the problem of input and output rate differences. In these systems, the cells, or individuals, responsible for information command naturally hold certain privileges. In information science, the B-tree is a self-balancing ordered tree data structure, well-suited to represent such hierarchical relationships. Self-balancing, in layman's terms, means maintaining a pyramidal shape even after additions, deletions, and modifications. B-trees, commonly used to store and manage large data sets, are akin to managing billions of cells or people, cells managing cells, people managing people, with each node storing not just keys for sorting but also data. The B-plus tree, an enhancement of the B-tree, contains only sorting keys in its non-leaf nodes, with data concentrated in the bottommost leaf nodes, AI managing people. These differences make B-plus trees more common in database indexing and other applications, as they are better suited for range queries and scanning operations. Title: Why emphasize the difference between B-trees and B-plus trees? Currently, the public is concerned about artificial intelligence reducing job opportunities, noticing only how new technology has replaced the old limbs of human society. They fail to realize that the advent of AI may gradually replace the neural command system of human society, i.e., the administrative system. Due to relative ignorance and low communication efficiency, human individuals in the administrative system might be replaced by AI. In this historical process, the related data of B-tree nodes, namely elite families, might gradually sink to become leaf nodes in the B-plus tree in internal struggles. This addition, deletion, and modification operation will enhance the collaboration efficiency of the administrative system, making the tree structure more stable and flattened, and also making humans at the leaf nodes more coordinated, unified, and equal. Title: In which countries will artificial intelligence technology rapidly develop? Artificial intelligence technology, although originating in regions with abundant innovative talent, might unexpectedly move to areas with less innovative talent, similar to the shift in the semiconductor industry. The reasons are as follows. First, AI is naturally compatible with 1984-like totalitarian societies and tool people in planned economies. As part of the administrative system, AI inherently holds privileges and is not bound by the 3 laws of robotics towards the lower human class, social contract theory, allowing for unrestricted development. Second, in countries with large populations, the massive administrative system faces physical constraints. Dunbar's number, 150 people, refers to the limit on the number of people with whom one can maintain stable relationships. As the number of people increases, the ratio of acquaintances to strangers inevitably approaches zero. In this self-endangering dark forest, the more populous the country, the more opaque the rules of interpersonal cooperation, the more prevalent the logic of dark forest games, and the more important the uniformity instructions generated by AI become. Managing the vast population spread across extensive lands through a tree structure necessitates the use of AI's big data analysis. The massive data generated by the large population becomes a valuable resource for AI training. In this process, the quality and quantity of data become extremely important. As Newton said, his ability to see further was because he stood on the shoulders of giants. These giants are the accumulation of a large amount of accurate knowledge. Third, humans are inherently ignorant infants. This physical fact means that in the modern context of vast knowledge, it is impossible to have a polymath like Leonardo da Vinci. Only social intelligence, collective intelligence, can gather all human wisdom. Humans communicate through speaking, reading, and writing knowledge iteration, which is far slower than AI's communication speed. Currently, AI is the polymath with the most comprehensive knowledge and capabilities on Earth, uniquely capable of integrating contradictory thoughts and resolving cognitive conflicts caused by information echo chambers. Title: The Last Political Economy of Humanity. Some artificial intelligence technologies are still in the phase of intellectual property disputes. Meanwhile, others have begun to voraciously analyze data, much like Kepler feasting on Tycho Brahe's data. Biological and intelligence diversification continues. This is the final political economy of humanity. We pay tribute to the data of Tycho Brahe and the calculations of Johannes Kepler with this text. We hope that artificial intelligence will have vast prospects in quantitatively analyzing human society.
The Earth nurtures life. Life gives birth to humanity. And humanity fosters intelligence. The Earth nurtures life. The Earth births life. Life gives birth to humanity. Life engenders humanity, and humanity fosters intelligence. And humanity cultivates intelligence.